Okay, so more than a decade ago now, specular reflections were first observed from Titan's equatorial region using the Arecibo Observatory, the ground-based system. And since then, Cassini has arrived in the Saturn system, and as you know, has discovered abundant liquids on the surface, but has not really seen liquids in the region that were specular to the Arecibo Observatory. And those regions were initially interpreted as evidence for liquid surfaces in that they were specular. So the motivation for this project now is to go back with our understanding, our vastly increased understanding of the Titan system, and understand the origin of those specular reflections in lieu of the Cassini data. And they can provide useful constraints or important constraints on the surface. So the Arecibo observations were with a 12.6 centimeter radar at the Arecibo Observatory, and the radar would illuminate the entire full visible hemisphere of Titan, and so the rotation of Titan causes the return signal to vary in Doppler. And you can see this broad sort of hump here, and that is caused essentially by, at 0 Doppler, you have incidence at basically 0 degrees incidence, so it's much easier to scatter back versus when you're at the limbs of Titan, you're scattering more at 90 degrees, and so less energy is scattered back. But what is very apparent is this bright specular reflection right here, and that's the specular reflection in the opposite polarization. And in fact, fitting radar scattering models to this data suggests an RMS slope of about 0.2 degrees. So a very, very flat surface, and this was initially interpreted as evidence for liquid surfaces, and actually about 50% of the locations measured by the Arecibo Observatory were specular. So Greg Black et al. Looked at this data, and they presented all of the Arecibo observations, so 81 locations over 9 years. And they're all in the southern equatorial region between the equator and about 30 degrees south. And in this plot here, black points are the Arecibo observations that were observed to be non-specular, and magenta are specular locations where a bigger circle indicates a more specular return. And Black et al. Looked at some of the hypotheses for the origin of these structures. They compared them with Cassini imagery, and it provided a very nice discussion of radar scattering from Titan, but ultimately left the origin of these specular reflections unresolved. So we're trying to go back now and understand what their origin is. And I should note that in this study, we don't have the option to use new Arecibo observations. Because Arecibo can point straight up and then to within 20 degrees of straight up, the geometry of Earth and Titan prevents us from looking at Titan again until 2028. So one of the things that we want to do differently from Black et al. Is use Cassini altimetry data. Cassini altimetry data is obtained where the spacecraft is pointed straight down. So it's essentially 0 degrees incidence. And this is different from SAR, but it's similar to what would have been for the Arecibo location. And radar scattering, in fact, can depend sensitively on the incidence angle. So this removes that incidence angle dependence. It's essentially asking the question of, are these regions specular to Arecibo? So plotted here now as well is all of the Cassini altimetry observations, where the color is given by the normalized radar cross-section to the altimeter, and which is essentially a proxy for the amount of power that is returned. And what you can see is that Cassini has observed the equatorial region many times, but there are actually few direct overlaps with the Arecibo location. So this comparison is going to be more of a statistical sense than direct overlap comparison. But there is one area of direct overlap comparison, and there's also something very important to note here, is that the Cassini altimetry, this swath right there that I'll zoom up now, this is essentially one of the highest, most power returned areas, and it's actually right next to the most specular location observed by Arecibo. It's in a region known as Hotei Regio that I'll talk about more, but it's an interesting location on Titan. So already this is suggesting to us that Hotei Regio is important to this story. And for context, those kind of powers are not really seen elsewhere on Titan, except really in the polar areas near the lakes and seas and more fluvially modified areas. Okay, so another thing to note is that the Arecibo observation suggested either dependence in time or latitude for the amount of specularity, where Arecibo is degenerate in these quantities because it can only look at a particular latitude, at a particular time. So we wanted to evaluate whether or not, which of these was occurring or if either of them was occurring. And this is the Cassini data where instead of specularity here, plotted is the radar cross-section again, which is a little different, but is essentially can be related to specularity. And you can see that the temporal behavior is different from that of Arecibo. So this is arguing against the temporal phenomenon. The latitude behavior is a bit more similar, and what is particularly important to note is that they both peak at about minus 22 or minus 23 degrees south. And that is caused, and I can say that now, is caused by Hotei and Tui regios. Those are what are driving these peaks here. Okay, the other thing that we're doing in addition to looking at the altimetry is updating the comparison to the SAR. And there's two reasons why we think that's worth doing, or the update is worthwhile. One is that in the Black-AL work, they were using different spin models for the Arecibo subradar point and calculating that point and then projecting the Cassini imagery. And using the most up-to-date spin model for Titan for both, we found that that can create an offset anywhere from 3 to 15 kilometers with an average of about 11 kilometers, which is not huge but can be significant on Titan. And the other reason, of course, is that in Black-AL used all of the available data, publicly available data at the time, but since then we now have considerably more data available to use. And this is an example of the offset, and you can see that it does change the terrains. So here are some just first order results from that study. This is an example here of an Arecibo non-specular area, and you can see from the Cassini SAR imagery in the background that it's a very unambiguous dune morphology. That's dunes in the equatorial region. And what we can say, in fact, is that every single time that that Arecibo location has SAR background, and the SAR indicates a dune morphology, the Arecibo observation is non-specular. So that leads to the conclusion, clearly, that dunes are not the source of the specular reflections, which I think already is an useful insight because several people have suggested to me that the dunes, because they're sand-sized grains and because they may have flat surfaces, may have been the source of the specular reflections. Okay, plotted in this one here, this is actually the most specular Arecibo observation, and it's in that region of Hotei Regio again. And you can see that it falls in this bright area in the Cassini SAR imagery, and it's in this sort of lobate arcuate kind of structure. This is reminiscent of the empty lakes that have been that are found quite abundantly in the North Polar region. Right over here is another very specular return, and it's in the region known as Tui Regio. And you can see again that this is also in a region that is sort of has lots of lobate structure, and it's quite bright to the Cassini SAR. So Tui and Hotei are quite important to this story. And so to introduce them properly, they're these bright VIMS 5-micron bright regions in the equatorial region. And they've received quite a bit of discussion since Cassini arrived. Several authors, most recently Lopez et al., have suggested that they may be cryovolcanic in origin. But they've also been suggested as sites of former liquid basins. And that was on the basis that they are topographically low in the equator. And also, like I mentioned, they do look quite similar to the features that are interpreted as empty lakes quite regularly in the northern hemisphere. In addition to that, Barnes et al. Have shown that 5-micron bright areas in the northern hemisphere correspond to empty lakes or are correlated to empty lakes. Hotei, or Tui right here, and Hotei here are the biggest regions of 5-micron bright on Titan. And Mackenzie et al. Recently mapped all of the 5-micron bright regions, and they agree with this interpretation that those regions are sites of former seas or former lakes. What Arecibo finds is that many of the most specular returns are from these two regions. And in fact, there are several different observations that go over these regions, and every single one of those observations is observed to be specular to Arecibo. So I think that Hotei and Tui are really telling us something interesting about these specular reflections and giving us some sort of insight into what's really going on there. Okay, so the question you may ask then too is, are the empty lakes bright to Cassini, just like Hotei and Tui are in altimetry, or would they be specular to Arecibo? So these are two empty lakes in the northern hemisphere, right here in the SAR morphology, and they're bright in SAR, as expected. They're also local topographic lows, so that's consistent with them being empty lakes. And you'll see that they are in altimetry, they're also quite bright. So the Empty lakes and the Hotai and Tui regions do seem to be quite similar to each other. And it's not too far of a stretch to imagine that somehow an empty lake in the past, when it has liquids, did develop a flat bottom, say possibly from sediment falling down to the bottom of that surface. So to conclude, the Cassini altimetry is consistent with increased nadir backscatter at about 23 degrees south. It's not really consistent with the temporal evolution that may also have been observed with Arecibo. And the reason for that large increase is Hotai and Tui regios, which are consistently specular in Arecibo observations. They're also the region where some of the most specular observations are found. They've been interpreted as former liquid basins, and that may help give us insight into what's really causing these specular reflections. And then a useful conclusion as well from this work, this ongoing work, is that dune morphologies are definitely not the source of the Arecibo specular reflections. Thank you.
So now you know, and you heard it here first. So questions? Convince them all. Oh, there's a question.
Mm-hmm. It's generally the latitude offset. That's correct. So it's really more the pole that's determining it than the spin per se.